Okay, geometry students, in this video we will be learning two other ways to prove that lines are parallel. Two other ways to prove that lines are parallel, and that will bring our total ways to prove that lines are parallel to 6. We will also be looking at two postulates today that are about parallel and perpendicular lines. Okay, so that is our goal for today. Go ahead and copy this heading down in your notes if you would please. Your heading today is parallel and perpendicular lines. Parallel and perpendicular lines. The lesson is 3.6. So please also copy that in your notes and include today's date if you would please. All right. Parallel and perpendicular lines, lesson 3.6, and include today's date. All right. Okay, let's continue on. Now, let's take just a second and review the four ways that we just recently learned to prove that lines are parallel. Okay, we just learned four ways to prove that lines are parallel. All right. Now you can write this down or you can just listen. It's up to you. You don't have to write this down. It's in your notes already, but you should know this. And that's what's so scary. If you don't know this, then you're behind. Okay, you should know these four ways. On an upcoming test or quiz, if I said list the four ways to prove that two lines are parallel, you should be able to list these four ways out. Okay, so here we go. We know that two lines are parallel if those two lines are cut by a transversal or intersected by a transversal in such a way that, here we go, the alternate interior angles are congruent, or the alternate exterior angles are congruent, or the corresponding angles are congruent, or, and here's the only one that's different, okay, consecutive interior angles are supplementary. Now, just real quick, not even a 30-second review, probably like a 15-second review, okay? Here we go. Alternate interior angles, number one, would be here and here would be a pair, and here and here. Alternate exterior angles would be here and here, there's a pair, and here, there's a pair. Corresponding angles would be here and here, there's a pair, or here and here, or here and here, or here and here. And then lastly, consecutive interior angles would be here and here. Those angles would go together, and here and here. Okay? And so just understand these angles here, if they're supplementary, if they add up to 180, then you know these two lines are parallel. All right? Okay, moving on. Remember, today we'll be adding two new ways to this list, so we'll have a total of 6 ways to prove that lines are parallel. Let's take a second and look at the two new postulates that deal with parallel and perpendicular lines. Now, these are not the two new ways to prove that two lines are parallel, okay? These are just two new thoughts that we're going to learn real quick that deal with parallel and perpendicular lines. So here we go. Okay, postulate number 10. Please copy this in your notes. Parallel postulate. If there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. All right? Please copy this in your notes. If there is a line and a point not on the line, then there's exactly one line through that point parallel to the given line. Okay, give it a second to copy that down. And then students, I want this in your notes also. Okay, so go ahead and put if we have line A and point A. Okay, so come over here and draw that. Here's line A, little a, and here's point A down here. So if we have line A and point A, notice if there's a line and a point not on the line like A, then there's only one line through the parallel point to the given line. Then, well, I'm not going to be able to draw this very well freehand, but you get the point. Then only one line parallel to A. Okay, so look, it's so simple, students. This is really common sense. I mean, if you have a line here and a point over here, how many lines can you draw through this point that are parallel to this line over here. Just one line, and there it is. I mean, there's no other line you can draw that's parallel to A. So all that they're establishing is a principle or a thought that if you have a line and a point not on that line, you can only draw one parallel line through that point, okay? I'm going to move on. If you need the supervising teacher to pause the video, that's fine. I'm going to go ahead and move on to the next point, okay? And here we go. Okay, postulate 11, the perpendicular postulate. If there is a line, this is the same thing, only now we're dealing with the perpendicular line. If there is a line and a point, please copy this in your notes, and a point not on the line, then there is exactly one line through the point perpendicular to the given line, okay? If there is a line and a point not on that line, then there is exactly one line through the point that's perpendicular to the given line. So if, and again, if I go too fast, just have the video be paused, okay? If, and to be honest, students, I would rather go too fast than too slow, because you can't speed a video up, but you can always pause it, okay? So I'm going to probably go decently fast, okay? So if I have line A and point A, so here's line A and point A, then there's only one line perpendicular to A through point A, okay? So if I give you a line and a point not on that line, there is only one line you can draw that's perpendicular to this line here that goes through this point. And here it is. That's such common sense, students. Look, I mean, how many perpendicular lines can you draw from A, not line A, from point A to line A? Only one. How could you draw another perpendicular line from A to A? I mean, if you draw another line, it's going to be slanted a little or slanted a lot. And that's all this postulate is saying. It's very simple. It's nothing tricky about it. Now, you'll need to have it memorized and know it for your upcoming tests and quizzes, sure, but it's really easy to understand. If you have a line and a point not on the line, then there's exactly one line you can draw from that point to the given line that's perpendicular. Okay? All right, continuing on. Now let's add those two new ways to prove that lines are parallel. Okay, so here they are. Here's the two new ways to prove that lines are parallel. Here they are. Theorem 311. Please copy this in your notes. If two lines are parallel to the same line, then they're parallel to each other. That's it. Please copy that in your notes. If two lines are parallel to the same line, then they're parallel to each other. It's that simple. Third time. If two lines are parallel to the same line, then they're parallel to each other. So write this down, please. If A is parallel to B and C is parallel to B, then you can say that A is parallel to C. Do you not see that? Okay, look. If A is parallel to B and C is parallel to B, they're parallel to the same line. A is parallel to B, C is parallel to B. So if two lines are parallel to the same line, then they're parallel to each other. A is parallel to C. That's it. That's all that it's saying. And look at the picture over here. It makes total sense. Please write this down. Here's A. Okay, there's A. Here's B. Okay. A is parallel to B, right? A is parallel to B. Now I've got to draw C parallel to B, right? C is parallel to B. So here's C down here. There we go. So if A is parallel to B, which it is, and C is parallel to B, which it is, then it doesn't make total sense that this line right here is going to be parallel to this line down here? Sure, totally it does. So last time, we're moving on. If two lines are parallel to the same line, then those two lines are parallel to each other. Okay, let that sink in. We're moving on. Okay. All right, theorem 312. Now this one here, you would think it would say something else. It says if two lines are perpendicular to the same line, you would think then it would say then they're perpendicular to each other. That's not true. This is really different, okay? In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Copy this in your notes and then come over here and copy this down, please. I want you to write this extra if-then stuff down. It's very important that you write this down, students. It helps break down the theorem or the postulate so you can understand it a little better, okay? All right, we're going to say if A is perpendicular to B and C is perpendicular to B, then A is parallel to C. Now, at first, when you read that, you might think it's a mistake and it doesn't make sense, but when you see a picture of it, it's going to make total sense, okay? So let's go over this again. If A is perpendicular to B and C is perpendicular to B, then A is parallel to B. And let's see this, okay? Look, A is perpendicular to B. So here's A, here's B, okay? Here's A, here's B. They're perpendicular. Now I've got to draw C so that it's also perpendicular to B. So here's C right here. And look at that. I've drawn A perpendicular to B. I've drawn C perpendicular to B. And when I do that, look what naturally happens. A is parallel to C. Okay? And that's what this theorem is stating here in Theorem 312. Okay, if two lines are perpendicular to the same line, then those two lines are parallel. Okay, we're almost done. Let's keep moving here. Now, in closing, I want to list out the 6 ways to prove that lines are parallel. Okay, and I do want this in your notes, so please copy this in your notes. Okay, here we go. I want you to list out the final 6 ways that we're going to study this year to prove that lines are parallel. Here we go. Number 1. Alternate interior angles are congruent. Number 2, and I'm going to go fast. You'll probably have to have the video paused, which is fine. Alternate exterior angles are congruent. Number 3, corresponding angles are congruent. Number 4, consecutive interior angles are not congruent, supplementary. Okay? Number 5, I probably should give a quick example of each of these. I know you are going to say, Mr. Earhart, you don't have to write it down. Just watch. Okay, look. If I have two lines cut by a transversal and this angle here is congruent to this angle here, that's alternate interior, then I know right away these two lines here are parallel. Number 2, alternate exterior. If I draw two lines and they're cut by a transversal and I mark this angle here congruent to this angle here, well, that would be alternate exterior angles being congruent. You know right away those two lines are parallel. Number 3, corresponding angles are congruent. Well, if I mark this angle here congruent to this angle here, those two angles are corresponding angles, so thus I know if those two angles are congruent that these two lines are parallel. Number 4, consecutive interior angles are supplementary. So if I call this angle here 80 and this angle here 100, those two angles there are consecutive interior angles and they add up to 180, so I know these two lines are parallel. Okay, now that's some good examples of what we're talking about here for 1 through 4. Now I'm not going to make you write any examples down for 5 or 6 because we just did that back here. We wrote examples down. Okay, but here's number 5. We just learned this one. Excuse me, sorry. We just learned this one. If two lines are parallel to the same line, then those two lines are parallel. Okay? Number 6. If two lines are perpendicular to the same line, then they're parallel. We just learned those two. So there's the 6 ways to prove that lines are parallel. That would make a great test question right there. And so you've got to decide whether or not you're going to learn these and memorize these or not. But that'd make a great test question, okay? So please know these 6 ways. Okay, moving on. I want you to copy this in your notes. I'll pause just a minute. I want you to write down, find the value of x that makes AB parallel to CD. Let's label this real quick. AB parallel to CD. Okay. And then right here we have 2x plus 2, and right here we have a right angle. So I'll pause just a second while you copy this in your notes, all right? Okay, now students, let me show you why this exactly lines up with what we learned today. Please listen to me, okay? Watch. We just learned today that if two lines are perpendicular to the same line, then they're parallel. Well, I noticed that CD right here has a right angle. So this line right here is perpendicular to this line here. So if I can make this line here also perpendicular right here, then I know these two lines are parallel. So really what I'm doing is this. Remember students, anytime that two lines are perpendicular to the same line, those two lines are parallel. So if I can make this angle right here, 2x plus 2, equal 90, then I know I've got a perpendicular line here. So that's all you have to do. I want to find out what x has to be to make this angle become 90. That's it. And once I know what x is, then this angle is 90 degrees. So bring the 2 over and make it negative, so you're left with 88. Divide both sides by 2, and you're left with 44. So what I'm saying is this. If I were to put 44 in for x right here, 2 times 44 is 88. 88 plus 2 is 90. When x is 44, then this whole angle here becomes what? 90. And as soon as this angle becomes 90, I have a right angle here. And as soon as I have a right angle there, then this line's perpendicular to this line here. We'll call it line L. So I have CD perpendicular to line L, AB perpendicular to line L. So if two lines are perpendicular to the same line, then they're parallel. So there we go. What is the value that x has to be to make these two lines parallel? X has to be 44 degrees. Okay? All right, let's try another one. Take a second and copy this in your notes, please. Be sure and put, when you copy this down, one arrow here, and one arrow here, and then 2 arrows here, and then 2 arrows here, okay? Take just a second, please, and copy this in your notes. And do a good, neat job, students. Take really neat notes and do a good job. Okay, it's very important to do that. Your notes, as weird as this sounds, your notes will be a lot easier to study if they're neat, okay? I would really make them neat. Okay, we're going to explain why A is parallel to C. Now look at this. Please take some really good notes. Okay, I have one arrow here and one arrow here, right? So I can state that A is parallel to what? B. Now I have 2 arrows here on B and 2 arrows here on C. So I can state that B is parallel to C. Now, here we go. The reason would be way back before we learned postulate, and I've forgotten the number. You can look in your notes. Postulate 10. Postulate 10. Notice we have A is parallel to B, and notice I have C parallel to B. So A and C are parallel to the same line. So how do I know that A and C are parallel? Postulate 10, guys. Okay, postulate 10. If two lines are parallel to the same line, then those two lines are parallel. Okay, there we go. Plain and simple. All right. Okay, moving on to the last problem. Please copy this in your notes. Find a value of x so that D is parallel to E. I'd like you to do this one on your own. It's actually very similar to this problem here, if not exactly the same. Okay, so go ahead and try this one on your own. You don't have to pause the video. I'm just going to pause a second while you guys copy this down and try this one on your own. Okay. Find a value of x so that D is parallel to E. Okay, now here's the first thing that I noticed. I noticed, and you should have noticed this too, students, I have a right angle here. Okay, we're going to call this A. Okay, So I have a right angle here. D is perpendicular to A. Line D is perpendicular to line A. So I'm going to write that over here. D is perpendicular to A. Now, if I could somehow prove, or not prove, somehow I could make E be perpendicular to A like this over here, then I'd be finished, right? Because if D is perpendicular to A and E is perpendicular to A, anytime two lines are perpendicular to the same line, those two lines are parallel. And that would be postulate 11. So, students, all that I have to do is make this angle right here a right angle. And as soon as I make that a right angle, then E would be perpendicular to A. So really it's pretty simple. Just take 5x plus 10 and set it equal to 90 and solve for x. Okay, bring the 10 over and make it a negative 10. So 5x equals 80. And then divide both sides by 5. And x would be 16. So if you were to put 16 in for x right here, 5 times 16 would be 80, and 80 plus 10 is 90. You would have 90 degrees. Okay? So now I can say that E is perpendicular to A. So if D is perpendicular to A and E is perpendicular to A, then I can definitely state that D is parallel to E, okay? By using postulate 11. All right, I hope this video's been a help to you. Sorry, my voice is getting a little bad here. I hope this video has been a help to you guys. The main thing you want to understand is we added 2 new ways to our list of 4 ways to prove that lines are parallel, and then also we learned 2 basic postulates back here. Okay, postulate 10 and postulate 11. And by the way, I apologize. It looks like, yeah, I should have said theorem. I apologize, guys. We all make mistakes. It should have been, hold on one second, please. Theorem 311. So right here, I should have said theorem 311. I'm sorry, guys. I apologize to you. My fault. Theorem 311 for this one. Okay. And theorem 312. Some of you probably caught that. I apologize. Your teacher's getting a little senile in his old age here. But anyways, there we go. Sorry about that. Okay. So theorem 311 is if 2 lines are parallel to the same line, they're parallel. And theorem 312 is if 2 lines are perpendicular to the same line, then they're parallel. Okay, so anyways, make sure you understand all of this and make sure that you study this. And if you have any questions, don't hesitate to call or email.